There we go. Okay, so for today, we want to look at just one little new thing. It's not much, not much. So we had a bunch of patterns that allowed us to solve binomial equations, so polynomials that had two terms, right? And we're able to do that by using our difference or sum of cubes patterns or our difference of squares patterns. And we looked at some examples of that yesterday. Okay, so today we're going to look at something different. Today we're going to look at problems where we're asked to do things like solve a polynomial equation where it can be written as a four-term polynomial. Like let's just start this one real quick, and then we'll come back to this later. But I want you just to see what the context is here. So if we were to, Sean, let's put those away, please. If we were to, well, what are we going to do first? With any polynomial equation, what do we always do first? What, Lauren?
Simplify.
Simplify, sure. And in what way? Combine like terms. We want to move all the terms to one side, right? Which side do we move them to this time? Move them to the left. Good, because whatever the leading term is going to be, the biggest power of x, we want to have a positive number of those, right? So we'll move everything to the left. And what's that going to give us here? If we move everything to the left, we're going to get 50x cubed minus 225x squared. Let's see, if I subtract 7x, what's negative 11x minus 7x? Minus 18x, good. And what's 90 minus 9?
81.
Good, plus 81. And notice that we set that equal to 0. Right? So we put it in standard form, it said equal to 0. So how many terms do we have in our polynomial? 4, right? So we need to come up with a strategy for solving a 4-term polynomial. We've only got one, and it doesn't work all the time, but when it works, it's a good way to do it. So the way we're going to do this, and we're going to go back to an easier one for our first example, is we're going to use a pattern. It's called grouping. So when there's a 4-term polynomial, all we do is this. We're going to break it up into two groups of 2. The first 2 terms are in the first group, and the second 2 terms are in the second group. In each of those terms, I'm going to set up kind of the template first, and then we'll fill in the blanks as we go. So from the first group, we're going to factor that into a greatest common factor, and what we might call the leftover. The leftover factor, or the leftovers, what we're left with after we factor out the greatest common factor. In the second group, and the second group is just added to the first group. I've got the first group, 2 terms, plus the second 2 terms. Here's the way the pattern works. We have to get the very same leftover that we got in the first group. For this to work, they have to be the same. And then the question just becomes, will that work? Can I get a greatest common factor that I can factor out to make that work? If I can, then the pattern works, and I'll show you what happens after that. If we can't, then we're done. We can't solve it that way. The ones I'm giving you, obviously, are the ones that work, because we're practicing this, but it doesn't always work. So let's go back to group number 1, and let's do this. What is the greatest common factor of x cubed and negative 6x squared? In other words, what's the biggest thing that I can undistribute? And like before, we've talked about this stuff before, you always want to think of this in terms of a number part and a variable part. So is there a number I'm going to be able to undistribute this time? No, I've only got a 1 for my coefficient here, so I can't undistribute anything other than 1, and that doesn't help me, right? What about variables? I could take out an x squared, couldn't I? Right? They've both got x's, and I want to undistribute the biggest power of x that I can. So I could undistribute an x squared. Okay, so then I need to know what's left over when I do that. X squared times what is x cubed? X. Okay, so I got an x left over from the first term minus x squared times what is 6x squared? Say it again. 6. And the other way I could do that if I wanted to is I could even just say, what is, for example, x cubed divided by x squared, and I get x, right? So that gives me the first term, for example. But I don't think you need to. I think you can just do it the way I just did. It's a little quicker. So then, second group. What do you know, what has to be true in the second group? Okay, the leftover has to be x minus 6. So now watch carefully how we would addition values for the greatest common factor. Probably the easiest way to do this would just be to say, well, what would it need to be so that I get back negative 16x? What times x is negative 16x? Negative 16. Okay, so let's just check to verify that that works when I distribute it. Well, negative 16 times x gives me negative 16x. Check. Negative 16 times negative 6 is what? Positive 96. So it works. Check. Okay, so it does fit the pattern. Okay, so now what? Now all we're going to do, once we've got this broken into greatest common factor and leftover for both groups, well, the leftover is a common factor. Remember, we said they had to be the same, right? So then we could just undistribute from each of the two groups. We could undistribute the x minus 6, and what's going to be left behind if we do that? What's left over from the first group if I undistribute the leftover? Oh good, I'm going to get my x squared from group 1, and then I've got plus whatever I get from group 2. Well, from group 2 I'm left with negative 16, right? And so then it just becomes x minus 6 times x squared plus negative 16 is just x squared minus 16. Okay, this one is done. I can't obviously break that apart any further because I've already just got an x to the 1. This one, could I go further? Does it fit any of our binomial patterns?
The one where you have that, the first one we do, where it's x minus a x plus b.
Okay, so almost. So it's this first one, isn't it? It's this guy right, whoops. Right, where is it? Oh, right here. Yeah, it's difference of squares, isn't it? A squared minus b squared is just a plus b times a minus b. It doesn't matter what order you write those factors in. Right, but if I look at this example, look, I've got x squared. How could I write 16 as something squared? 4 squared. Yeah, so this is really just x squared minus 4 squared, right? And so that would break apart into x plus 4 times x minus 4. And then I've already got this x minus 6 out front, right? So now this is, our directions ask us to completely factor this, right? So we want to break it up into factored form, break it apart as far as I can. Well, I'm done. I can't go any further than that. X minus 6 times x plus 4 times x minus 4 is equal to what we started with. Okay? So that's what we call factoring by grouping. Now let's practice another one, just a slightly harder one. So if we're completely factoring, we broke this, before we move on to another one, we broke this completely apart. But if we're not, I want to look at this one more time. What if we were instead? I want to show you a difference here, how this is actually easier if you're not completely factoring. What if we were solving the equation instead? If we were solving the equation, solve when this equals 0, right? So if we're solving this equation, we'll just borrow all the work we did from before, right? When we factored by grouping, let's just stop right there, right? We got down to this part where it became x minus 6 times x squared minus 16. Okay, so then that's how this broke apart, right? It broke apart into those two factors, and we want to be able to solve it. Well, once we have it factored, we can just use the zero product property, right? We can set the factors equal to 0 and solve. So the first one's pretty easy. If I set x minus 6 equal to 0, what's x equal to? Chris, what's x equal to? If I solve that. I'm trying to find the zeros of the 0 of that first factor. What makes it 0? 6, yeah. So there's one solution, right? How about the other one? If I apply the zero product property here and I set the other factor equal to 0, do I have to factor that to solve it? No, I can just isolate x directly, right? Right, so what would I do? What are the 2 steps to solve for x there? Add 16 and square root. Good, so we get x squared equals 16, and when I square root both sides, I need a plus or minus, right? So I get x equals plus or minus 4, right? Square root of 16, and so I end up with my 3 solutions. Either x equals 6, x equals 4, or x equals negative 4, right? The point being, if I'm not forced to completely factor this thing, I don't necessarily have to break it all the way down. I just need to break it down into small enough factors where I can solve the factor equations, right? Okay, so how about something like this one that we started? How many terms in the polynomial? 4. So what's my strategy for 4? We just did it. What do we call it? Grouping. Okay, so we're going to break it into 2 groups, right? I split it into 2 groups of 2. And we've got to get from our first group a greatest common factor and a leftover, right? Plus, second group, we know we have to have same leftover factors. And the whole thing is equal to 0. So group 1, what's the greatest common factor of 50x cubed and 225x squared? 25x squared, right? We know that 25 goes evenly into 50 and 225, right? So we can factor out 25, and then we can take out an x squared. Well, what are we left with? 25x squared times what is 50x cubed? 25 times what is 50? 2. X squared times what is x cubed? X. Okay, 25 goes into 225 how many times? How many quarters are there in $2.25?
No,
9, right? Yeah, good, 9. 4 quarters per dollar, and I got 1 extra one, right? So I'm going to get 9. So 9 times 25x squared would be 225x squared. So first group is done. Riley, what do I know has to be in group 2 then? Without doing anything, I can fill in one of those. No? Tony, what's it got to be?
Here's something. 2x.
2x minus 9.
Thank you. So, right, because we know that, remember the pattern, we know that whatever the leftover is from group 1 has to be the leftover from group 2. Okay, so, Cairo, what's going to go in here then? What times 2x would give me negative 18x? Which number? I ask you again, what times 2x is negative 18x? No. Negative 9. There you go. Okay, so if we distribute the negative 9 times 2x is what?
Negative.
Check. That works. Negative 9 times negative 9? 81. Check. It works, right? Okay, so we know the pattern's going to work. Now, next step. Let's see, Randy, what am I going to do now? I know the pattern's going to work. I've got my group 1 and group 2, and they have the same leftovers. So now, what can I undistribute from each group? Think back to the last example, right? Last example, we undistributed the x minus 6, right? Because that was the same factor in both groups. It's a common factor. So what's it going to be this time? the 2x minus 9, this whole thing, right? Because now look at the structure of this. In group 1, how many factors are there in group 1? 2. I've got the red factor and the blue factor, right? Of course, I'll do that. How many factors in group 2? 2. Negative 9 and 2x minus 9. Well, when we factor out the greatest common factor, what is a common factor? It just means the same factor, right? So I've got the same factor being multiplied in both groups. So I can factor that out or undistribute it. So then this gives us 2x minus 9, and what's going to be left over? 25x squared, okay, plus negative 9 is the same thing as just minus 9, right? Okay, and that's all equal to 0. So now this is broken down far enough to where if I set each of these factors equal to 0, that's all, I can solve those equations, right? So what am I going to get from the first equation? If I set it equal to 0, what's my solution going to be, Chris? 9. Well, no, if I solve that for x, what am I going to get? 2 steps, but you can do it in your head. But I got to add 9 and then what to get the x by itself? Okay, so what do I end up with? 9 over 2. There's one solution, right? Okay, how about other one? Now I've got this other factor here. What if I set it equal to 0? 25x squared minus 9 equals 0. No, I know, Jeremy, I know he's got this. Carol, what are my 2 steps going to be to solve for x? I've got my reasons. Why? What's? And then what? No help. She can get this. She can get it. So I'm going to add 9. Then what? Okay, divide. Good. So x squared equals 9 25ths. So now final step. What am I going to get if I square root? Plus or minus. Well, what's square root of 9 25ths? I think you do. What's the square root of 9? 3. What's the square root of 25? I heard it. So we get 3 answers: 9 halves, positive 3/5, and negative 3/5, right? Okay. All right, one more. I'm going to let you work. Sure. Okay, so what about this guy here? Now this time, notice that they're only asking for real solutions, so that might make things easier. How many terms in the polynomial, Sean? 4. 4. Good. I get x to the 4th plus x cubed plus 27x plus 27, and it's all equal to 0. But I've got to break this apart into factors, so I've got 2 groups of 2, all right? So Dominic, first group, what's going to be my greatest common factor from the first group? What's the biggest thing I could undistribute from x to the 4th and x cubed? X cubed. Good. So there's my greatest common factor. Very good. What am I going to be left with, JJ? If I undistribute an x cubed times what is x to the 4th? X cubed times what is x cubed? 1, right? And if you're not sure, just distribute and see if it works, and it would, right? So plus group 2. What's my leftover gonna be? What do you think? Randy, what's my leftover gonna be on this side?
Is it x plus 1?
It is. It's x plus 1. Good. You know they have to be the same. Very good. So then what's gonna be, Brittany, what's gonna be my greatest common factor? What times x is 27x? 27. Does that work? Let's see. I get 27x. 27 times 1 is 27. It works. Right? Okay, so now, Riley, what can I undistribute from both groups? Not a 1. What have we done the last 2 times? X plus 1, right? X plus 1. And whatever fills in the leftover factors, remember, they have to be the same, so that's what we undistribute. Let's see, Juliana, what's going to be left over from group 1 when I undistribute the X plus 1? So if that gets factored out, what's left behind?
Is it X?
Mm-hmm. Plus, what's left over from group 2?
27.
There you go. Okay, here's where we can, things, depending on what kind of answers we're looking for, things could be easy or a little bit harder. If I'm just looking for real answers, remember from yesterday, hopefully, right? We talked yesterday about if we're, well, the first one's simple. We don't even have to write out the equation. What's the 0 that goes with X plus 1? Negative 1. So one solution is negative 1. Okay, what about this one? X cubed plus 27. I want to find the values of X that make that 0, right? If I'm just looking for a real solution, I can make it simple. I don't have to do anything tricky. If I want to solve this equation, how can I, if I'm looking for real solutions, what are the only 2 steps I have to do? Subtract 27 and cube root, right? I can isolate the X, and that's going to give me the real solution, right? But if I want to find all the complex solutions, I would have to write that as a sum of cubes, right? And use the pattern. What's this asking us to do? This one's only asking us to find the real solutions, so I don't have to do the whole factoring pattern thing. I can instead just isolate X. So if X cubed equals negative 27, if I cube root both sides, Robert, if I cube root both sides, do I need a plus or minus? He says yes. Do we agree? No is right. We only do a plus or minus if we're taking an even root of both sides, right? This is an odd root, so I don't need a plus or minus. That's the good news. The bad news is I only get the real solutions, which is enough here, though, right? So what is the cube root of negative 27? Vincent, what's the cube root of negative 27? What times itself is negative 27? No, there's not, you're never, now, so if we're taking a cube root, we're never going to get i's, and I'm glad you brought that up, because what I is the square root of negative 1. What's the cube root of negative 1?
0.
What times itself is negative 1?
1.
Negative 1, right? Cube root of negative 1 is negative 1. Think about it. Negative 1 squared is positive 1. Cubed is negative 1, right? I'm just multiplying by negative 1 each time. So in general, the cube root of a negative is always going to be what? It has to be negative. Yeah, so what's the cube root of negative 27? There we go. Get those 2 answers, right? Okay? All right. Grab Chromebook. Have at it. You can work on stuff.
I'm not going to get it.